Greetings and salutations, and thank you for clicking on the video. Today, it's the beginner's guide to the Bash terminal. This is the scariest part of Linux for new users. You don't need to use a terminal to use Linux. Many distributions provide very nice GUI desktops, graphic user interfaces, that give you all of the point-and-click comfort that you're used to. However, in Linux, Bash is a big part of the system. And if you ever run into a situation where you need help with a problem, chances are, if you are working with somebody in a forum or somebody's helping you directly, they're going to tell you to open up a terminal so that they can help you to fix the problem. Also, the terminal is very powerful, and once you learn your way around, you might find that you like working in a terminal better than doing the point-and-click thing, because it allows you to do very complicated things with just a few little commands. So in today's video, I'm going to give you the crash course. This is the beginner's guide. We're going to go through a whole bunch of information very quickly. And the idea here is to provide one video that will help people who want to get started with Bash. There are a lot of great tutorials on YouTube about Bash. Most of them are multi-part series, and they're very long, and they go into a great deal of detail. I myself posted one of those a little more than a year ago. However, this video is a crash course. If you sit down and you watch this video from beginning to end, you are going to have the very basic concepts and tools you need to actually use the terminal, and most of what I'm going to show you is where to get more information. So it's pretty cool. Now you can see why the terminal would be intimidating. When you open one up, all you get is a blinking cursor. It doesn't tell you anything. Well, that's the difference between Bash and a GUI. A GUI interface is one that will give you options. You can pretty much intuitively figure out what you're going to do. In the terminal, when you're working at a command line, it is assumed that you know what you want, and so therefore it doesn't offer a great deal of help as you roll along. Bash assumes that you know what you're doing, so be careful as you roll through, because there are some things that you can do that might damage your system. We'll point those out as we roll along, so pay attention to those cautions. So the first thing that you're going to want to learn how to do is figure out where you are and what you're looking at. So the very first command that I'm going to teach you in the terminal is ls, which stands for list storage. And when you run that command, and you run a command by typing it and then pressing the enter key, it will give you a list of everything that is in the current directory that you are logged into. The directory that you're logged into is usually your home directory. And that is told to you right up front there by the prompt. This is Ubuntu, and this is pretty much the typical prompt that you will get, and it tells you a lot of information. First of all, it tells you who you are, which might sound like something that you should already know, but there are occasions when it's nice to know that information and have it on the screen. And it tells you exactly what computer you're logged into. With Bash, you can use the remote shell or the secure shell, SSH, to log into other machines. So if you have more than one terminal up, it's kind of nice to know exactly what machine you're working in. And then finally, you'll see that little tilde character. Well, that's an abbreviation for your home folder. Tilde always represents your home folder. And finally, the last thing that you see is the $sign. The $sign indicates that you are logged in as a standard user, which means that you have regular privileges. You cannot enter a command here and run it as an administrator unless you preface it with another command or you switch to the administrator's account, which is known as root. So that's what the prompt tells you. And ls tells you what files and directories you have with you. Before we go any further, it's probably a good idea that we take a look at the basic Linux file system so that you can get an idea of what we're dealing with here. This is called a tree. It's upside down. If you turn it right side up, then it would look more like a tree, because we start out at root, and root is the base of a file system on a Linux or Unix machine. And everything is in root, which is usually a bunch of directories. All directories are files that contain more files. So you can have files and directories in the root directory, and then each directory can contain more files. The one that we're probably going to be most interested in is the home directory. That's where all of the users who have accounts on the computer have their files stored. It's in there somewhere, and that will make more sense as we roll along. So ls shows us what we have in the current directory. The next command to know is pwd, where we can print the present working directory. So pwd will tell you exactly where you are. And in this case, it gives us the full path. This is not abbreviated. So a path means that if you go from the root of the file system to wherever you are now, this is how you get there. So in this case, we go from root to home to a directory called Joe, and that is me. Directories and folders, the names are interchangeable. That's something else to keep in mind. You may hear people refer to them as folders. And that is because way back a long time ago in computer science class, when they were first teaching us all about computers, they likened directories to folders in a file cabinet. So the hard drive would represent a file cabinet, the directory would be the folder, and of course files were within those folders. So when you're working in a graphic user interface, usually we call those folders because they're represented as cute little pictures of folders, just to make sure that that's understood. PWD tells you exactly where you are in the file system and gives you the full path. That is called an absolute path. There is also something called a relative path. And a relative path is how you get to something from where you are right now. And it assumes that whatever you're trying to get to is in your current working directory. So in this instance, I could, for instance, type in ls and then type in documents. And I'm going to use a trick that I'm going to tell you about in just a second there to fill that up. And now it will list everything in the documents folder. And I used a relative path. Well, I can also issue this command this way. I can say ls root home Joe, and then I can do doc, type that correctly and it would help. Now I'm going to get exactly the same output, and that is because I used a absolute path. So you need to understand the difference between those two things. So let's clear the screen here and let's issue ls again, because I want to show you another thing that ls does. And this is another important concept to understand about commands, is that they usually have options. So if I use a dash or a hyphen and then I give ls the A, it's going to show me everything in the directory because there's more than what the eye can see. Some files and directories in Linux are hidden, and they are hidden because they have a little dot character in front of them. So there's way more in your home directory than you just see with plain ls. And then ls has more options that you need to know about. So ls, and then the next command would be l. What this will do is it'll give us a long list of everything, which shows us all kinds of information about the directories. If I issue that same command and now I tack A on there as well, now I get everything in the directory. Don't worry about all of that gobbledygook on the screen. We'll talk about that as we roll along, and it will start to make more sense. So ls and pwd, those are the first two commands that you need to know because it tells you where you are and what you have to work with. The next command that I want to talk about is the change directory command, because this one's really important. This is how you get from one place to the next. So this will also show you the next concept that we want to get into, which is called auto-completion. So let's say that I'm sitting here at my home folder directory and I want to go to the documents folder. Then I would use cd change directory, and then I could just type in doc and it will autofill it for me when I press the tab key. This saves you a lot of typing. Remember that people who work at a terminal, whether they be programmers or sysadmins, they're lazy. We want to minimize our typing, so there's all kinds of shortcuts. In my original Bash series, I didn't cover auto-completion because the old school way of teaching it is that you type everything. But since then, I have rethought that, so that's why I'm introducing that concept. Now, you will notice if I only type do, and then hit the tab key, that it doesn't do anything the first time. If I hit it twice, it now lists everything that could possibly be auto-completed. So it'll give you a list of all of the files or directories that you're looking for that you could use. So in this case, well, let's change our mind. We want to go into downloads. So now I type a W, autocomplete again with the tab key, and now I'm in downloads. Once I'm there, if I want to get back to the home directory, I got a couple of options. Anytime you want to go up one level from wherever you are, just put that ... in there. And that tells the system, hey, I want to go one level up. Or in the case of the home directory, I've got the ability just to type CD. So let's go and we will go into downloads again, CD, boom. CD with no argument basically tells the system, take me home. And also, there's another way to do this, which is rather redundant, but it's good to know. The home directory is abbreviated by that tilde, so it'll do the same thing. It'll take me home. So that is the basics of how the CD command works, and it's one that you will use a lot because you can move around the system. So let me show you another thing about CD here and auto-completion together, which makes life really simple. So I'm going to go ahead and switch to my Documents folder. And now I'm going to list the storage in there. Oops, I forgot to issue the command. Oops. There we go. All right. I'm going to make typos as this rolls along. I make a lot of typos while I'm typing and talking, so please forgive me. It will happen, I know. All right, so here we are. And if I just list the storage in here, and if I scroll up, you'll notice that we have some directories in here that have very long names with spaces and all that kind of stuff. Well, dealing with directories and file names that have spaces in them can be a bit of a pain. So this makes auto-completion really useful. So if I want to CD into a directory I have called bash scripts and guides, notice that it fills that in for me. And not only does it fill it in, but you see those little slashes there, the backslashes. Those are called escape characters. So if you are going to create or access a file that has spaces in it, then you use those to tell the system, yo, ignore the space, act like it isn't there. And that will allow me to get into that directory, no problem. Those of you who are already using Ubuntu may notice that my prompt is not showing the full path to where I am. That's a modification that I have made. Ubuntu usually will show you the full path. So on your machine, it may say :documents, and then it would be whatever directory you happen to be in. To get back to the home directory, boom, there we go. Okay, so that's the basics of using CD with auto-completion. One more thing that's related to CD that is very useful. Let us say that you are in your Downloads folder. Type that correctly. And you need to jump over to another folder on the machine, which is way somewhere else on the file system. So in this case, we're going to be in etc. Well, you could CD over there, and then you could use a CD command to get back. But there's another way to do this. And the command for that is push D. And then give it your directory. And now what it will do is, you see, it's saying that we've gone to the etc directory into the downloads directory. And I can work here for as long as I like. And then I can use a command called popd. And it takes me back to right where I was. Yes, you could use two CD commands. Why is that useful? Well, what if you don't remember where you were? What if you end up working in the etc directory for a long time and you go, wait a minute, what directory was I in? I'm not really sure. Well, if you use push D and pop D in that particular situation, you'll always jump back to where you were and you won't lose your place. You won't have to remember, well, what directory was I in to get that file? Well, there you go. So there you go. That's how you navigate the system very basically. So the next concepts that we want to get into is understanding what we're looking at. So let's do that ls again, and let's give it an A. And, well, let's get into a directory that has something in it. So I'm going to go back to my home directory. We'll go to A, which will show everything. And now you see we have a list here, and we're not really sure what we're looking at with some of these things. Linux does not necessarily need or use file extensions, especially when working at a command line. If you're coming from Mac or Windows, you may be used to seeing extensions on things. Like if you create a text file with a word processor, it may have an extension called doc, or in the case of LibreOffice, it would be ODT. And that's telling you what kind of file it is. Well, Linux doesn't care. It doesn't need those extensions to function. It can figure out what a file is on its own. So the next command that I want to show you is file. So let's say, for instance, we don't know what that little .face file is. All we've got to do is issue the file command and then give it the file name, and it tells us that it's a JPEG image. Well, what about that weird one that's you got? Now you notice I'm not going to type the whole thing. We're using auto-completion. Now it tells us that that's a sound file, and as a matter of fact it says it's a WAV file. So file will tell you what you are looking at. Well, let's do that with one more just to prove a point. File, and let's do this thing here called SSR. Well, it's telling me that that's a directory, which means it contains more files. Now in my terminal I get things color-coded, which means that depending on what kind of file you're looking at, you may have a different color. That's very useful. Not every terminal that you sit down in front of is going to give you that lovely option. So it's nice to know how to figure out exactly what kind of files you're looking at, and that is files. So the next thing that you're probably going to want to know is, how do I find a file? I mean, there are thousands of files on this system, and I need to look for a file. Somebody's telling me I need to edit such and such file, and I have no clue where this file is. Well, there's several ways to do that, but the easiest one there is in Linux is the locate command, and it takes file names or parts of file names. So let's say that somebody told you that you had to edit the fstab command or file. You have no idea where this is. If you use locate and then you press enter, it gives us everything that has the name fstab in it. Now you'll notice there are a lot of references to fstab. But the first one is the one we are really interested in, which tells us that it's in etc. And the locate command uses a database to find things. So one of the things that you may have to do if you want to make it useful is update that database. If you just installed Linux like an hour ago and you're trying to do something with the system, chances are locate will not work at all because this database does not exist. What Linux distributions do is they usually set the system up to update the database for locate once a day. So if it doesn't work today, it may work tomorrow. But you can issue that command yourself, and then you can update that database. So let me show you how to do that so locate becomes very useful to you. We're going to jump ahead in our concepts here because I'm going to actually issue this command as the super user. I'm going to have root privileges to do this because to run the update db command you have to have root privileges. So if you're working on a computer in a company or at school, you may not have root privileges. You may not be able to use this command this way. You're going to have to ask your administrator, hey, update the database for locate so I can find this thing. But if you're running your own computer, then you should have administrative privileges. So it's sudo update db, and it's going to ask for my password to make sure that I have authorization to act as the super user, and then I get no output. It actually does it. If this command had never been run, it was the first time that you were running it, it may take it 2 or 3 seconds to run. You won't see any output on the screen, but when your prompt comes back, you know that your locate database is nice and ready to go. So the next command that we're going to take a look at is which. And the which command finds other commands for us. So if you know what a command is, but you don't know where it is, or you don't know if it's installed, this is how you can find out. So we will type which, and in this case, we're going to look for a little command called cal, which doesn't do anything but print a calendar on the screen and tell you what day it is. So if I do that, it tells me, oh, yes, it is installed on the system, and it is in a directory called user/bin/cal. Cal is the name of the file. So now that I know that that command is installed, I can run it and it prints me a calendar. It's a very simple command, but it is very useful and it's a good one to know. And the last one that I want to show you is history. The history command shows you all of the commands that you've already typed. What bash does is it keeps track of all the commands that you issue to the system. And you can access that in many different ways. I'm only going to show you two in this particular video, but you can always look for more information about that. You can use this in multiple ways. So the first thing that you can do is just use your up arrow on your keyboard, and it will show you the last commands in the order in which you typed them. So you see all of the commands I've used so far to demonstrate are listed here. So if you type a command and then you go, oh, wait a minute, hold on, I don't remember exactly what I typed, then you can just scan up your history and look for that command. You can find it again. Now, if you want to see what is in your history, and you need to find a whole bunch of stuff, then you can just type in history, and make sure I typed it correctly. Yes, I did. And if you press enter, now it lists everything that you've typed in. History usually keeps up with the last 1,000 unique commands that you've typed in. And I'm going to show you a little bit later on in this video how to make this even more useful. So if you don't want to sit there and look at them one at a time, you can just roll up and down. And then you can also issue these numbers in lieu of the command itself. Now, if you want to find out how to use that, you're going to use what I'm going to show you in the next part of the video to figure out how to do that. So that is history, and that is how that works. So the next thing that you need to know about is getting help, because there's plenty of help available to you. And I'm only going to show you a few options for getting help. There's a lot. If you're sitting at a terminal and you're trying to figure out how to use a command or how to do something, there's a lot of ways that you can get information without having to go to a web browser, without having to have the machine hooked up to the internet. There is a lot of help information that is already here, and all you have to do is know how to get to it. So the most simple command is what is. So if you want to know what a command does, you just go and what is this? What does it do? Then this will give you a very short little explanation. So we looked at the cal command, which is that calendar command, and it says it displays a calendar and the date. That's it. That's all it does. So what is very useful if you're just trying to figure out what a command does, and there's a lot of information. And then there is another way to find out information about commands that you might not completely understand the syntax. You may want to do something with the system, but you don't know which command to use. So it'd be kind of nice to kind of give the system a pointer and say, hey, I want to do something that involves time, but I don't know exactly which command to use. Well, in that case, you can use apropos. And then we're just going to give it time. Now watch this. We're going to get a bunch of output on the screen. I'm using my mouse, by the way, to scroll up and look through that. And so it shows us all kinds of different commands that are related to things that have to do with time. Very useful. Well, if you need more intense information, the next one to know, and the one that I use more than any other command, is just the good old man command. Man he's your friend, man. So if you need to know what's going on, you got to ask the man. So how do you use man? Well, the command is man. And in this case, I'm going to show you the manual page for the man command. And then the page pops up. Now you can use the arrow keys to go up lines and scroll up and down. You can also use the space bar to scroll up and down through all of this information. And you can read more about the command that you're trying to find information about. Not every command on the system has a man page. Like, for instance, I don't think there's a man page for CD because it's a shell function. There really isn't one. So you might not find one. Let's see if there's a man page for CD. I don't believe there is. No, there's not, because CD is pretty straightforward. But there is a what is for CD, I think. Okay, so what is CD? Well, see, it's not in the manual, so therefore you can't figure that one out. So every now and again you might run into something that isn't there, but of course in this case you can always look it up online. Most of the commands that you're going to use are going to have a man page, so therefore you can get to them from what is, I propose, or the man command. So that's how you get help. Pretty simple, huh? I told you this was easy, man. It's not as hard as people make it out to be. Okay, so the next part is working with files directory. Directly, and we're going to work with files and directories directly. I said it properly, isn't that awesome? So the first command that I'm going to show you is how to make a directory. You might want to do this. We're going to do this in this case. We're going to call it junk. So I'm going to make a directory called junk. By the way, if I wanted to make more directories, I could just keep typing here. It'll take input all the way until you get tired of typing. So if you need to make a whole bunch of directories, you could just do it all at once. But in this case, we're only going to make one for the video. So now I have entered the command. I got no output. If you get no output, that's how you know a command works. And we're going to see if we've created our directory by running ls. Why, yes, we have that directory. So let's go into that directory. Now we are in junk. And our directory is very empty. So let's talk about creating files. I'm going to show you a really nifty command here called touch. The touch command is more useful than it may appear. Touch does two things. If you issue the touch command and then you do it with a file that already exists, all it does is update the date on that file. Every file on your system has a little date, a little thing in there that records the last time you accessed it or did something to it or changed it. So touch will do that without actually doing anything to the file. And it can be very useful when you're working with things like backup programs. If you want to force the backup program to back up a file, you could touch it, and then it would have a later date than the last backup, and it would just suck it on over. But touch also has another curious function, and that is if you touch a file that does not exist, it will create that file. There's nothing in it, but it will create the file. So in this case, we're going to create a couple of files. We'll create file 1, file 2, and file 3. And we'll turn touch loose, and now we have created those files. Pretty cool, huh? Make sure they're there. There we go. We have our files, and they're in the directory. So we can start playing around with these files. Now, the first command that I think that people should know is copy, because this is the one that saves your butt. If you have to go edit a file or you want to change something about a file, but you want to keep a copy around, this is how you would do it. So copy will make a copy in the directory that you're working into. So I'm going to tell it that I want to copy something from the home directory, and I am going to give it a file name to work with. In this case, we're just going to pick a system text file that holds information. We'll use this later on. So there is bash rc. Okay, and now we've got to give it a new name. So I'm just going to call this bash rc without the dot so we know exactly what we're looking at. So what I'm telling the system now is that I want to copy this file, and I'm getting it from the home directory, and because it auto-completed, we know it's there. See, that's one of the things about autocomplete. It's almost like ls without doing ls. If it auto-completes when you try and complete it, you know the file exists. And then I'm going to tell it to put it in this directory that we're working on right now because there's no path in front of the second file name. Boom, there it is. So let's see if we have our file in there. So that's copy. So if I was going to work on that bash rc file, okay, I would maybe want to copy it into something that would be a backup of that file so I could go back to it later. Okay? So in this case, I'm just going to call it back. And now that file should appear. We're good to go. So I can change things in my bash rc file, and then if I screw it up really, really bad, I know that I have a copy somewhere and I can go back to the other one. So the next thing that we need to learn how to do is to rename files. And we do that with the move command, or mv. mv has two functions. It can either move a command from where we are now to some other place in the file system. If we give it the name of the file we want to move, and then we give it a path and another name, it'll just take that file and stick it wherever we want it to go. But in this case, we are more interested in renaming a file. So let us say that we did screw up our bash rc file. So what we're going to want to do is we'll do bash rc.back, and we want to move this back into bash rc. All right? Didn't give us any output. You're not going to see that it's done anything. But if you had made changes to the original bash rc, you would find that that file has now been moved. And if I list the storage again, look, the .back version of bash rc is no longer there. That's because I renamed it bash rc, I rewrote over the file, and there you go. I can also do the same thing here. I can move the contents of a file. So let's take our same file that we've been playing with, and we'll do mv bash, and now we're going to move it into file 1. Okay, so now the bash rc has gone altogether, but all of its contents are in file 1. So that's using the move command. Very powerful command, and I suggest that before you start playing around with it, you look at the man page for that one. Now we're going to look at removing files, taking files away from the system. This is the rm command, and it is extraordinarily powerful. This is one you need to be afraid of just a little bit, because rm can be as precise as a scalpel, but if you type it in with the right arguments, you can blow away huge amounts of data and it just goes poof. And unlike working at a GUI where you have a trash can, there is no way to get files back after you remove them with the remove command. They are gone. There is no undelete. They just disappear. That's one of the things that makes Linux very secure, is that when you delete a file, it disappears. It's gone. It's going to be very difficult to retrieve that from the hard drive after you delete it. So be careful with rm. And the simplest way to use rm would be to issue rm against a file, and then let's say we wanted to get rid of file 2, that would be it. It would just go away. A more powerful way to use rm would be to use rm and then use a wildcard, which is something that you can do at a terminal. If you want to refer to more than one thing, then you can use a glob character, which is an asterisk, which basically tells the terminal, I want to get rid of everything. So the most powerful way to do that would be to go rm and the star. What that would do is it would remove all the files from our directory. Now, we're not actually going to do that, but if I just wanted to get rid of files that had the name file in them, I can put the glob on the end there, and now what it does is it tells the shell, it says, okay, I want you to remove all of the files that start with the word file, and if there's any characters after that, then they count too. Let's make a directory in here so I can show you the next thing about rm that you need to know. And that is, we're going to make one, we're going to call it junk2. So make sure it's there. Now if I run the rm command against junk2, watch what happens. It says, I can't do that. It's a directory. I can't get rid of it. So if you want to get rid of files, then you don't need to add any arguments. But if you want to remove directories, then you're going to have to give it an argument. And that argument is going to be rmr. And now, if I would issue the star command, it would literally take all of the files and directories out of there. So what the R command does, it puts it in recursive mode, which says remove everything in the directory, including other directories and files, and then remove the directory itself. That is a very powerful version of rm, and you should be just a little bit afraid of it, okay? So let's actually put rm to work here, and I'm just going to get rid of file 3 because we didn't do anything with file 3. Now, the next command that I want to show you, at first glance you may think, well, that's kind of redundant. I don't need that. But I'm going to show it to you anyway, and it is the rm directory command, or rmdir. Now, what this will do is, remember we put that thing in there, that junk2, or did I already get rid of it? Hold on a second. Let me see where I'm at here. Nope, it's still there. So if I do rmdir and then give it junk2, then it should remove that directory because there's nothing in it. All the remove directory command does is remove directories that don't have anything in them. If you have files in there, it won't work. You're going to have to use rm with the R argument there, the recursive. Now you're saying to yourself, well, how is that useful? Well, what if you have a bunch of empty directories? You've been working on a project and you've created a bunch of directories, there's nothing in there, you just want to clean things up a little bit. Then the rmdir command can be very useful. So let's go ahead and create a bunch of directories, and then we'll get rid of them in one shot, and I'll show you how it's done. So we'll make dir, and we'll call it dir1, dir2, dir3, just a bunch of stuff. All right. So now you see we have all these directories in there. And I just want to get rid of them. There's nothing in there. I'm done with them. So if I do rmdir and then give it the glob, it gives us some output because it's saying that file 1 and file 2 aren't directories, but it still did the job. Watch. All gone. So that is the basic file navigation right there. How you can manipulate files on your system. And there's more to that. Of course, each one of these files has, each one of these commands that I just showed you has a lot of different options, but you can look that up on your own. And as you get more proficient, you'll learn how to use those particular options. Well, so the next thing that we're going to want to learn how to do is do something with these files other than create them and remove them. What if we want to put things in them? And one of the things that you're going to be doing at a terminal a lot is working with text files. The entire Linux system, or pretty much most of it, all of the settings are contained in text files. And to change things about your system or to fix things, a lot of times you have to end up editing text files. Even the front-end applications you use on your GUI are actually just editing text files in the background. So we'll show you how to do that directly. Now, as you recall, I put some text in file 1, so there's actually something there. And if I just want to see what's in there, I will use the cat command. Let me go ahead and clear the screen here. Make it a little easier. So we have the cat command. And the cat command will just list everything in a bunch of files. So if I give it file 1, and then I turn it loose, it's just going to read the command and print it on the screen. That's all it's going to do. And it printed a bunch of stuff. You can see everything that's in my bashrc file. We can't really, it's a long file, so we got to scroll up here. I'm going to show you how to deal with that in just a little bit, but that's what it does. So what if we had something in another file? So I'm going to show you another thing that cat does. I'm going to get a little ahead of myself. And I'm going to open up cat, and then I'm going to tell it that whatever I do with cat, I am going to put into a file. You're going, what are you doing, man? This is really weird stuff. Believe me, this is useful, and it'll make sense later on, but I just need to stick something in file 2 for right now. So I've issued this command, and basically what I'm saying is anything that cat comes up with, I want it to stick it in this file. Okay? So now I get a blinking cursor, and I can type in hi. And then I'm going to use Control-D to tell the cat command that I'm done. Well, what did I just do? Well, let me show you. Let's cat file 2. Well, look, it reprinted exactly the same thing on the screen. That's because I added text to it using the cat command itself. This is one of the most basic things that you can do with a terminal. Like I said, at this point, this might not appear to be useful, but if you need to create small little text files very quickly, cat will do that for you. So what else does cat do? It sticks files together. It's actually short for concatenate, which means take a bunch of information and stick it in one place. So if I cat file 1, and then I cat file 2, and tell it file 2, watch what happens. We have all the stuff that was in that bashrc file, and then we also have all that information stuck down at the bottom. So that's cat, and it's more useful than you think it is. So let's look at some other ways to read what's in text files. I want to introduce you to a couple of little programs called More and Less. More is very old, and you're not going to use it a whole lot, but without knowing what more is, less doesn't make sense. So we'll start with more. So now if I say more, and then I give it a file name, I'm going to give it file 1 there, and I turn it loose, look what happens. Now I can page through the file using the space bar. So I'm seeing it one page at a time, all that crap that's in that configuration file. When I get down to the bottom, it returns me to the prompt. That's more. That's all that more does. And if you issue more and then you go down 2 pages and you realize, I don't really want to be here, then you could do the Q, use a Q, and it'll just dump you right back to the prompt. That's all it does. That's more. That's it. And it's a pager. It just pages through a bunch of text in a terminal. That's nice. But there is a more advanced command that does the same thing. So let's do less file1. The less command is more than more. Because now that we're using less, I can use arrow keys and go down one line at a time. I can also scan back up. I can actually use the space bar. I can search for text within the file. Less does a whole lot of things. So if you're having to read a text file and you're getting, just overwhelmed by stuff scrolling off the screen, remember to use less. When you're done with less, Q. It lets you out. So Q is for quit when you're working with less. So there, now you know more and less, and you now know that less is more. Now we need to actually edit files. Now I showed you how to use the cat file to throw some text in a file, and I introduced you to some concepts that you're probably going, I don't get it. But what if we want to actually edit a file? There are many, 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 many text editors available for Linux. But one that is probably the easiest to use and the most intuitive and is going to generally be available on most Linux distributions that you sit down in front of is called Nano. Nano is a very powerful little text editor. So let's just give Nano a file name. And just to keep this easy, I'm going to give it file2. And if you don't have a file and you just start Nano and then give it a file name, it's going to save with that file name. I'll show you that in just a couple of seconds. So there's the little file I created with cat. And now I can use my cursor to come down here and type and change things. And then down here at the bottom of the screen, you'll see that we have lots of options. Let's add something to this file. Let's just say, let's just put, let's say BYE, right? BYE is like when you're leaving. So I'm going to throw that line in there. And then with Nano, I use Control-O to write out the file, and it confirms the file name. It tells me that I wrote it out, and when I want to get out, I use the Control key and the X, and I'm gone. So we can cat that file to see the changes. See, it added by. So that's what it does. It's a text editor. Now there are a lot of functions within there, like you can cut text, and then you can move things around, you can mark things. We're not going to get into that. You can play with Nano on your own. So if you just want to play with Nano, just type in Nano and then enter, and now you can do, you can put whatever you want in here. Let's say hi, and then if you want to leave, you don't want to save it, no problem. Just choose no, and you're out. You're gone. It's pretty simple and pretty straightforward. So Nano is an awesome file. Now, before we move on from working with files, I want to tell you about a little concept called redirection. Now, I already showed you redirection with cat earlier when we created that file. And that just means that I take the output from one program and put it into a file or into another program. And this is very useful using these different commands. So, like I said, with cat, if I do cat, and I give it that little bracket right there, it's going to put this in a file, file2. If I want to append and not create a brand new file from scratch, then I can use cat and put 2 in there, and it will append to the bottom. So if I want to append to file 2, now we're just going to add the text to the bottom, put in more stuff, Control D to tell it we're done. Yep, there we go. And then if let's just use Nano. Open up Nano. You see, I added more stuff on there, so I appended to that. If I did exactly the same thing, and I only used one of those little brackets there, we will do the same thing, and then I'll just put in hi this time. And Control D to tell it I'm done. And now if I go back up here and Nano that file again, look, it's all gone because we created a new file. So that's how you direct output from a program or from anything that generates output on the screen. You could stick it in a file. That's what I wanted to say. And the other way to do that is piping. So I'm going to show you piping, and that's taking the output from one program and sending it into the input of another. Remember our history command we looked at earlier? Okay, so if I type in history, it just scrolls off the screen. If I use the pipe character, which on a US keyboard is above the return key, and you press shift to get it, it looks like two vertical lines or a single line. And then I'm going to put that into less. Watch what happens. Now I'm running less, and I'm seeing the output from that command, and I can page through it. That's because I took the output directly from that command and put it into the less program. When I used cat to create files, I was taking the standard input, which is your keyboard, and I was sticking that directly into the cat program and then turning it into a file. So that's the concept of redirection. If you ever see that, that's what that does, and it's highly useful. You'll find all kinds of uses for it. So we're going to give you one last demonstration of redirection before we move on. Let's take the ls command. I'm going to tell it I want to see everything. I'm going to say I want to see everything, so I'm going to give it all, and I want a long list, and I want to see that directory. And then I want to put this into a file. We will call that file, watch what happens. Oop, let me fix that. Put a U there so that makes sense. lsout.txt. So what we're going to do is we're going to list the root directory, and we're going to show everything in it, and we are going to have a long list, and we're going to stick it in a file. I saw absolutely nothing happen on the screen. Did it work? We'll find out. We'll do ls. And now you'll see that we have a file there called lsout. So let's ls, or rather less, lsout.txt. Look, it's everything that's in the root directory, but instead of putting it on the screen, we put it in a file. So that's basic redirection. You have now been taught. Your life will never be the same once you know how to do that. Okay, moving on. So the next thing that we're going to do is jump to another concept. We've learned how to navigate the file system. We've learned how to get help. Now we're going to talk about working with users and understanding how different users relate to each other on the system. So let me go back to my home folder. The first command that I want to show you is sudo. We've already seen this in the video because it's something that you need to know. Sudo will allow you to do something as another user, and most of the time with most modern Linux distributions, sudo is how we give administrative privileges to a regular user. So if you install Ubuntu or anything based on Ubuntu or Debian or Arch, and you do not have a root account set up, chances are you have a sudo account ready to go. It's su, and it stands for substitute user do. Super user do is another way to look at sudo. Some people call it sudo. That's incorrect, but even I do that occasionally, so you'll have to forgive me. So how do we do this? Well, if we have a command that we need to run as with elevated privileges, we can just do this. So in this case, we'll run the update db command as we did before, and you get the idea. It asks for the password, and now I'm running this as the root user. You can make sudo stick around. You can become the root user. And yes, you'll see in a lot of Linux documentation that you can also use the su command, which we will look at next. The preferred method for doing this in Ubuntu-based distributions is to use sudo s. It is safer than su. If you use the su command, there is a danger that you may type in the right text and activate the root account. If you activate the root account on an Ubuntu system or any system that has it disabled for security, then the account becomes active, and therefore somebody could hack into your system and get to it. So in Ubuntu, to act as the root user for a while, you can just type in sudo and then s. And you notice what changed there. First of all, it didn't ask for my password. The sudo command runs a timer in the background. So if you issue one command and a minute or two goes by, you may be able to issue another command without it asking. If that timer times out, it'll ask for your password again. That's for security. In this case right now, I am running as root. So if I wanted to issue a command to the system as the root user, then I would be able to do that now. And I could issue one command after another. To get out of this mode, you type in exit. We'll talk about exit a little bit more later. So type it in correctly so it works. And now you'll see that I've turned back into myself. With the sudo s command, it'll tell you that you are root and what machine you are at. And you'll notice that this turned into a hashtag or a pound sign, whatever you call that thing, that's telling you that you're running as the root user, and the root user has total privileges. It is not a good idea to run as the root user all the time. Running as the root user can be dangerous. You can type in commands and you can wipe out big chunks of the system or change things. You can make mistakes here that will definitely mess up your system. So be wary of running as root. The rm command as root will erase anything on the system. Doesn't matter what it is. System files, makes no difference. You can blow out just the whole thing. So the next one that we want to look at is su, and this changes you to another user. So the su command works like this. If I want to become another user on the computer, let's say that I want to be Cindy, then I would type it with this syntax. And the su command with a space, then a dash, and then Cindy, what that says to the system is, I want to become Cindy, and I want to change over to her home directory, and I want to load all of her settings in bash. If I do not give it a dash, then it won't do that. I'll just jump in as Cindy, but I'll still be in my own home folder. So let's try it both ways, and we'll see what happens. So if I do this, and then I'm going to put in her password, and as the administrator on this particular system, I have everybody's password. I have access to it. That's part of the fun of being the administrator. You're all powerful. So if I do pwd over here, you'll see that now I am in her directory, so I have access to all of her files. Any command I issue here will be as Cindy, and it will operate in her section of the computer. Now to get out, I type exit, and then it says I've logged out, and it dumps me back. Now if I do su and just do Cindy, and I didn't put the dash in there, watch what happens. It's going to ask for the password. It's saying that I'm Cindy, but I'm in my own home directory. So if you want to change something about Cindy's files, I would have to navigate it to her folder manually here. If I just wanted to run a quick command over here, this would be fine. But it's important to understand that that is how su works. Now I'm going to show you with su how to become the root user, but I do not recommend that you do this with Ubuntu for the reasons that I previously stated. However, some distributions of Linux create a root user, and if you have access to that account and you have the root user's password, then you may want to do it. So if you just want to issue a command as root user, you can just do su, enter will attempt to log you in as root. Okay, I'm not going to do it, but that's how it does it. If you want to become the root user and you want to navigate to the root user's home directory, then it is su and a dash with no name after it, and that will take you, you are now running as root on the system. It does work in Ubuntu. I don't recommend that you do it. Okay, so the next thing that we need to know is how do we figure out who's logged into the system? Well, that's really easy to do. There's a couple of commands that tell you that information. And this is going to be useful if you are on a system that's owned by a corporation or a school, or let's say that you have a computer at home that has several accounts on it, and you want to know if anybody else is logged into the system remotely, or their account is active, or whatever the deal is. So we use users to tell me that. And it says that I'm actually logged in twice because remember I have a GUI up and running and then I'm using a terminal emulator. So I'm actually logged into the system twice. If Cindy was logged into this system from a remote shell, for instance, or she had left her account active and I had switched to it at the same machine, then I would see that she was logged in as well. So we can show that just by using that SU. And then I'm going to jump in as Cindy real quick. I don't need to change to her environment to do this. And we're going to SU to Cindy. And it's going to ask for Cindy's password, and I give it to the system. Now watch what happens when I do users. Well, it's still telling me that I'm logged in as myself. Okay, hold on. Let's do it this way. Let's see if this works. Let me go ahead and get out of there. Let me switch over completely. It may not tell me. This may not work. I may actually have to log in from another terminal to do that. So let's try that again. Yep, still logged in as myself because I'm actually just masquerading as Cindy. She's not technically logged in. If she was, then we'd see her name up here. But anyway, that was a good shot, and it actually taught me something about the users command that I didn't know. So that's cool. See, I learn all the time too, just playing around with this stuff, showing you guys stuff. Okay, and the last command that has to do with users I'm going to show you is ID. This gives you all of the pertinent information about your account. It tells you what your ID number is, and it gives you a bunch of information. This can be very useful if you're trying to figure out why something doesn't work. And what this is doing is it's just showing you the line that is entered in the user's. There's a file that lives in the etc directory called password, and in the password it has all this information. It's just spitting it back out at you in one line. So for instance, if you're trying to figure out why you can't move a file from one place to the other, you may find that the system you're on has given you a different user ID number. Your ID number, for instance, might be 1003, and you're trying to move to 1000, and it doesn't accept the input. It just goes, permission denied, I don't know who you are, I don't know what's up. It can happen. So it's something that's kind of good to know right there, is how to get this information quickly about any user. Like I said, that is something that will become more apparently useful the more you get into the terminal. Okay, I'm only going to show you one more command, and then I'm going to show you how to kill some processes, and you've actually got a really good start here for working in the terminal. So there are a lot of options for users that I haven't shown you. You can create users, you can add yourself to a group, you can do all kinds of things, and there's lots of commands to do that, and you can research them on your own. When you're first starting out, you're probably going to want to do those kind of things from the GUI. I'm going to show you something else that you probably want to do from a GUI because it's available in every file manager just by going to the right-click menu and going on Properties. But it's nice to know how to do it from the terminal because you may find yourself having to do it from a terminal, and it's nice to have a little bit of an idea of how to do it. So let's talk for a second about file permissions. So I'm going to go into Documents, and then I'm going to list the storage, and I'm going to list it. I'm going to make a long list here. It's going to show me all this information. And you notice over here on the right-hand side of the screen that all of these files have all this gobbledygook right here. And when you first start out, there's a dash, and then it says RW and dash and R. These are file permissions, and it's one of the things that makes Linux very secure, is that every file on the system is owned by somebody. And other people may or may not have permission to look at that file or do things with it. And you have total control over that. So when you look at a long list, the first thing that you see here is the permissions. And these are the links to the file. Don't worry about that. That's something you can find out more about later. Becomes useful later on. And then we have who owns the file, which in this case is Joe, and what group it belongs to. It belongs to a group called Joe. So these permissions right here, the first three would be my permissions, Joe as the owner. The second would be group, and the third would be everybody else in the world. Then it tells you the size of the file here, and then it tells you the last modification date and the name. It's all there. So let us go ahead and clear this screen, and we'll jump over here to another graphic that I have. It's going to make this really easy to understand when we're talking about all of this stuff. So permissions are stored in 3 groups, and each one of those groups represents a byte of data, and there are 7 bits within that byte. And yes, that is correct. Nobody type on there, well, a byte is 8 bits. Yes, it is, but go look it up in the book. I know what I'm talking about here. There are 7 bits in a byte in this particular instance, and each one of those bits represents a permission. So the 3 basic permissions that we have that we can give to a file is that you can read it, which means that you can actually open the file and look at it. And then there's the write permission, which means that you can write to the file or you can delete the file. You can change it in any way. And then the last permission is X, and that is your execute permission. That means that this file contains code that the system can actually execute. Okay? And we can set those permissions by assigning the actual bits that represent each one of those permissions in the groups. So the first group there, which is user, which would be me, in this case, it is set that I can read, write, and execute the file. Read is worth 4 bits. Write is worth 2 bits. And execute is worth 1 bit. And we can use that knowledge to our advantage to change the permissions on any file in the system. Okay? I'm going to show you how to do that right now. So, if I have a file, let's get to our junk directory. And we'll see that we have a list of files in there, the stuff that we were, oops, sorry. There we go. All right, so let's do the list in long form, and then we can see all the permissions. So let's say that we have put a bunch of stuff in our file called file1. We want to turn that into a program. Let's say that we have written a bash script, and we want to make that executable, so the system will treat it as a program. Well, there's 2 ways that we can do that. The first one is to use the change mod command, or change mode. We just skip the E. And then we can use what is called a symbolic way of doing this, which is usually the easiest way to do this when it comes to setting a permission to write execute. So we just do plus, and then we do X. And basically what we're telling the command is, make this file executable for anybody. And then we give it the file name next. And in this case, we're going to do file1. And it took it. So let's list the storage. Let's list the storage long ways so we can see the attributes. It didn't do it. I know why it didn't do it too. I knew I'd make mistakes, gang. Don't worry, you'll make mistakes too. I used a capital X and I didn't know what I was talking about. Now do it. Okay. Now list the storage. And you can see that that particular file now has the execute attribute on it. When you want to just make a file executable, easiest way to go. Now that symbolic system goes on. In my bash series, I tried to show how that works, and I have a mental block about making that work. I got to be real honest with you. I have never been able to use the symbolic syntax for the change mode command. I just can't do it. So what I do is I cheat and I use the numbers because it makes it so much easier. So let's play around with this a little more. Let's do change mode. And this time around, I'm going to take those bits that I wanted to show you guys about. Let's say, for instance, that I wanted to make a file here. Hold on, it's not going to work. Okay, glad I caught that. Okay, would look stupid. So if I put 700 in there, what have I done? Well, I'm setting the read, write, and execute bit for me, and everybody else doesn't get no play at all when it comes to this file. So we'll do that on file 1 because that's the one we've been working with. Boom, and then ls the thing, long, and you see now that I'm the only person that can do anything with this file at all. And then I can change that once again by very easily. Let's say that I want to be generous, and now I want people to be able to read the file, so but they can't execute it. If I put 4 there, because remember that the 4 bits represents the read, then it will work out, right? So let's do file and do file 1, and we'll list the storage. Yep. There we go. And now I've made it so other people can read it, but I'm the only person that can execute it. That's it. So you get the idea. So whatever you put in there was going to do what you need it to do. Now, most of the time you'll be working with these 3 numbers. If you want to be able to read and write the file yourself, and you want other people to be able to read it, then you can do 644. And what that's going to do is it's going to make it a pretty standard file permission there. So you got to do LSL, dude, or it won't work. You got to show everything, man. Gosh, you can't type, dude. All right, see, now we've put it back to pretty much to where it was before. Ubuntu, by default, by the way, creates permissions that give the group write privileges as well. If you want to change that, this is how you can do it right here. So the other one that you probably use a lot is 755. So if we go in here and change this to 755, now when we list it, you'll see that everybody has write privileges, but only you can actually write to and change the file. One thing to understand before we move out of this particular session about changing file permissions. Very important that you understand this concept. Directories and files handle file permissions differently. So if you wanted to create a file that everybody could write to, no matter whether they were in the group or just everybody on the system that has access to the file, then you could use 777 as it's illustrated here. Or you can make it restricted where people can only read the file, and in that case it would be 644 for just writability and readability. 6 would be that mean that you could read and write as the user, and then 4 and 4 would mean that the world and people within the group would be able to read the file. That's how it works with files. With directories, you have to set the execute bit if you want other people to be able to see that directory. So when you're working with directories, when we did the file, 755 is pretty much the same thing as 644 is for a file. If you do not set the execute bit on a directory for anybody else, they won't be able to list the directory. They won't be able to get into it. If you don't set the read bit, they'll never even see it. If you don't set the write bit, then it's just like it doesn't even exist. So it's a little bit different there. So when working with directories, you would use 755, and when working with files, you would use 644. If that file happens to be executable code, 755 would be the one that you would use the most. I know it gets a little bit confusing, but that's kind of how permissions are. Even people who are advanced Linux users like myself, every now and then scratch their heads because something doesn't work and you don't know why. Well, that's why it's because it's a little confusing, but it's very secure that way. Okay, so the last thing that we want to talk about before we wrap this up is that we want to show you some basic ways that you can kill programs and processes. You want to be able to manipulate the system. If you get into something, you want to know how to get out of it. That's the point that I'm trying to make here. So the first one that I'm going to show you is how to kill a process that's running in the terminal. You may type in something and you don't get a prompt. You might run a command and it starts doing something and you get into something, you need to stop it. And to do that, you would use Control-C. So to demonstrate that, I'm going to use a command called watch. And what watch does is it basically reruns a command every 2 seconds. So it's in this case, we'll run the free command, which shows us how much memory is in the system. So we're going to watch free. Now basically every 2 seconds this is going to update, and if anything changes it's going to tell me. But you notice I have no prompt because this thing is just running and running. To kill a command like that, you use the Control key and the letter C. Control-C kills a command. It's dead, it's gone. So if you find yourself doing something and you don't know what's going on or something freezes up, Control-C just may get you out of it. The next thing that I'm going to show you is how to kill a command. This is any process that's running on the computer. So this happens all the time. You might run a program and that program misbehaves, for instance. So in this case, let's run Firefox. I'm going to open up my Firefox browser, and when it gets open here, I'm going to stick it behind this terminal that we're looking at. And you'll be able to see it through the terminal because I have a little bit of transparency on this terminal. Well, let's say Firefox, it starts messing up on you and it's not working properly. You can kill it. And the command that we'll use to do that is kill all. Firefox. So if you want to kill Firefox, and this is something that you've started yourself. You actually own this process. You have the ability to use it. It's something that or kill it. That's something you started as a user. Kill all only works for that. You can't kill something that somebody else opened up, logged in as another person. There is a way to do it, but you're going to have to figure out how to do that with super user privileges. In this case, it's just something you opened up. Firefox has locked up, doesn't work. I need to get rid of it. Now it's gone. It just went through and found every process that's running on the system that has to do with Firefox, and it got rid of it. And it works with any application that you know the name of. Okay, so you could use which to figure that out. So for instance, let's go back to the which command and put in Google. I didn't find that. So let's find Google Chrome, because that's another one that might lock up on you. Okay, there's Google Chrome. So if you're running Google Chrome and it locks up, you want to kill it. If you can open up a terminal, then you can figure out exactly what command it is to use it. In this case, it's Google Chrome, and then you would kill it. That simple. Actually, I think that you can just put in Chrome and it will work there as well. Try them both ways if you actually want to use this to kill Google Chrome. I had to kill Google Chrome not too long ago because it locked up, and I think I just put in Chrome. But you get the idea, okay? Not trying to confuse you, just trying to point it out that it might not work the first time around. You might have to play with it a little bit. And the last thing that I want to show you is how to get out of a bash session. So I've already showed you this several times, but I want to show you what it does. If you are logged into a terminal and you're done working, you want to get out of that terminal. Let me just open up another one here. And I want to get out of here. There's a couple of ways that I can do that. The first is to type in exit. And this is the one that you're going to want to use if you're logged into a real terminal, not a TTY, or rather you're logged into a TTY or a real terminal. I haven't covered that in this video, but that's something you might learn about later on. If you're using a terminal emulator or a TTY, you can always log out by typing in exit. And in this case, it just closes it up. You can also do that by using Control D, which is the command that tells the system, hey, I'm done with all the input. And it'll just get out, and it'll close out for you. If, like I said, if you were at a real terminal that's not a program that's running on a GUI like we're using here for the demonstration, then when you log out, it may log you out to a screen that just says log in. That's so the next person can log in, or you can log back in yourself. The log out command also works, but usually it recommends that you use exit. So for those of you who have played with this for a long time, there you go. And finally, every time I do one of these videos, people ask about this. So I'm going to tag this on the end, and I'm going to show you some very useful things that you can do inside of the terminal when it's running at an emulator. Okay, these commands may or may not work at a real terminal. These are mainly for an emulator, but they're still quite useful. So we've already talked about Control D. The next one is the Control C command, or rather Control L, which redraws the screen. So if you have a bunch of output on your screen, you just want to clear things off, Control and L will redraw the screen, and it'll get rid of all the stuff and give you a nice clean blank screen. You see me use that one all the time. And then you can also change the text size in a terminal emulator, and this works with most terminal emulators like and I know it works in Terminator, it works in GNOME Terminal, it works in XFCE Terminal. Pretty much anyone you're going to come across, this will work. So if you want to increase the text size, you use the Control and the Shift key, and that gives you the plus character. And now it makes the text size big. And you see now it filled up the screen and stuff. It's going kind of crazy on me a little bit there. Okay, well, I closed my whole terminal. Let me open that back up again. I don't know, got confused there or something. Let's do that again. So to make the text larger, you use the Control key and the Shift key to get the plus character on the keyboard, and you make it bigger. And then, to make the text smaller, let go of the Shift key and hit the minus character, and now the text will become smaller. So that's how I make text bigger and smaller on the fly. See, if you don't hit Shift, then it'll show the equals and you know it's not working. So let's go ahead and get out of that. Of course, the command is not found. So that's it, gang. There is your this is your crash course to the terminal. We sat here and went through one lesson, and I have introduced you to a whole bunch of concepts. And I want you to go off and I want you to do research on this. If you're new to Linux, I want you to open up your terminal. I want you to create a junk directory. I want you to create files. I want you to play, and I want you to learn more about it, because Bash, it's universal. It's on every machine that you sit down in front of these days. Even Windows can run Bash. And if you know how to do it with Bash, you can do it anywhere that you go, even on like little Internet of Things devices. A lot of them you can log in and get a Bash screen of some sort. It usually uses a little program called BusyBox that has a few of the familiar commands in it, but it's still, you can manipulate the system that way. You can do your router that way if you have access to it. It's pretty awesome. And there you go. That is it. Thank you for watching the video. I do appreciate it. For more about Linux, check out freedompenguin.com. Also, check out Easy Linux on the web. Find out what that's all about. And if you want a copy of this wallpaper, that's on easylinux.com. You can look at that, click on the thumbnail, and then download it from there by saving the image. And also check out Easy Linux on Facebook if you would, and if you do that, give it a like. I certainly would appreciate it. Thank you for watching. I hope that you found this video useful, and if you did, please share it. I would appreciate it.